Does anyone know what a cuboid is? Maxim?
Is it a cube?
It's yeah, it's a bit like a cube, yeah, very similar. Eva?
Isn't it kind of like a rectangular prism?
It's a rectangular prism, yes. It's you know the way a square would be a cube, a rectangle would be a cuboid. It's like a box. Yes, or a rectangular prism. Yeah, so we're thinking about, I don't know if you're able to draw a 3D box on your page, but we'll give it a go. You draw two rectangles that overlap like that. The starting point. Once you've done those two rectangles, join the top left corner to the top left corner of the one above it or to the side of it. Top right corner, bottom left corner to the bottom left corner, bottom right corner to the bottom right corner. And you should have some kind of 3D looking shape. The better you get at these, the more of those lines perhaps you could leave out. You want to just create some sort of a box like that. Those people who are good at 3D drawings and art would probably be better than me at this, but there's two examples of how you could represent 3 dimensions on a 2-dimensional page or board like me. All right. So if I want to get the surface area, so I want to paint this box or cuboid or rectangular prism, all the same thing. So this is a cuboid or rectangular prism, or don't want to be too fancy, you can call it a box for now. If I want to paint the whole box, and it's a closed box with a lid and everything. First of all, I need to think about how many surfaces I need to paint. How many surfaces are on the box? Alexi, how many surfaces are on that box? 3? I can see 3.
Look at the last one.
Okay. Mateo? 6, I think. Yeah, 6. 6, yeah. The front, the back, the 2 sides, and the top and the bottom. Okay, but I need to be able to see. At the moment with a 3D drawing, I can't see all those sides. So I'm going to convert this into a 2-dimensional drawing. So this at the moment has 3 dimensions. Well, kind of only has 2, but we're imagining it as 3. I'm going to convert this into a 2 dimensions. What's it called when we convert and unfold a box into its 2 dimensions? Anyone know what that type of drawing is, Eva?
Net.
It is a net diagram, yes. We're going to look at a net diagram. Right. For you guys, you can put this underneath. I just need a little bit more room, so I'm going to put it here. So I'm going to try and do this box as a net diagram. Let's start with the section we can see. That is the front. Let's put some dimensions on this box. So let's say that's 6 centimeters across. Not a very big box. It's 4 centimeters in height here. And it goes back 2 centimeters. So it's not very... It's a pretty tiny box. But that front of the box, I could probably put some dimensions on it. It is 6 centimeters. I saw, not meters. 6 centimeters this way and 4. It's the bit I'm looking at. It's a good place to start. So that's the front of the box. If I want to do a side, so the side would attach here. Yeah. Side of the box. So I'm unfolding it up. Side would attach here.
And then
I need to put some dimensions on this. The side, you can see that this bit would be this bit, I think. So this is 2 centimeters. What's this length? Is it 6 or is it 4?
it's 4.
I think it's 4, yeah, because it would correspond to that side. It would have to attach here, so 4 centimeters. Well, the other side, which you can't see, would have to match this side. So they're going to be in like pairs. This is the other side. It would also be 4 centimeters by 2 centimeters. That's 3 of them done. Okay. What would attach up here? So at the front, I'm looking at this. I think that's going to be the top of the box, I can call it. Top. We attach something like that, try and put it perfectly in the corners. Now if you want, you can do this freehand or draw a little ruler. It's up to you. Top of the box, I think it'd have to match the front here at 6. You can see that it would be 6 across. 6 centimeters. Oh, how far back does it go?
2
I
centimeters.
think it's just 2, so maybe my scale is a bit off here. I'll make mine a bit smaller, you don't have to. Just trying to make my scale fit. Yes, so you can see the top of the box would be here. I'd have to go back the same amount as this, so 2 centimeters. Therefore, the bottom of the box must match that too. So the bottom of the box, 6 centimeters across, we already have that there, but 2 centimeters deep. Am I done?
No.
What am I missing?
The back.
The bit we can't see at the back. I have the top and the bottom. That's the flap at the top.
The same size as the front. 6 centimeters.
I say that this is the back of the box, and it would have to match with the front of the box. Yes. 6 centimeters across here, and you can see all these are 6 centimeters because they all match. But 4 centimeters. This is the exact same as this, but on the other side it can't see. There's our 6 surfaces. That is called a net diagram, if you know over that. Net diagram. So if you're asked to draw a net diagram, you've got to unfold the shape. And now we go about trying to find the surface area. Maybe you can do this faster than me. Off you go if you can. Surface area. So there are 6 surfaces, we just found them. Got to find each area separately and add them up. Same as a compound shape. This looks like it's just a compound shape now. We just split it up. It's been split up nicely into rectangles for us so we can find the surface area. So I'm going to find the surface area of the front of the box first, because I started with that when I was drawing. Front of the box had dimensions 6 and 4, so the area would be 6 times 4. I'll get my answer for that. 24 centimeters squared. Because of the symmetrical nature of this box, the front and the back would be the same, wouldn't they?
Yes.
Does the back, they have the same dimensions, they have to match perfectly, so therefore they have the same areas. So perhaps I'll just do front, well, I'll put back and front are going to be the same. I just got to multiply that answer by 2, this is 2 of them, and therefore 48 centimeters squared in total between the 2 of them.
Isn't it huge?
No, it's still on area. I'm not looking for volume. Remember, area is just the surface. Right? I'm painting it, not filling it. 2 sides I'll do next. So I'll do the 2 sides, side and side. I'll do those together. They're both the same dimensions, 2 and 4. 2 times 4, 8. Because there's 2 of them, I'll multiply 8 by 2. 16 centimeters squared. So that's these stuff. So I'm doing them in pairs because I know they match. And the last 2 on my left wing.
Bottom at the top.
Bottom and top, yeah. Top and bottom. What's my dimensions?
2 and 6.
Yeah, 2 here, 6 there, and this one also 2 and 6, of course. So 2 times 6, 12. There's 2 of them, 24. Job done. Almost. What do I need to do, Curly? I have all my answers here. I want the total surface area. I want just one number at the end, so what would I do? Charlie? Add them all up to get the total. I want the total. I don't want them in separate bits. I want the total. So add them up. This plus this plus this. Has anyone worked it out? Eva?
88.
88? Nikita?
88.
Sam, 88, okay. Yeah, I think you're right. 88 centimeters.
Mr. Lawrence, you prefer 88 centimeters